this video, we will be discussing about find minimum diameter after merging two trees. There exist two undirected trees with n and m nodes numbered from 0 to n minus 1 and from 0 to m minus 1 respectively. You are given two 2D integer arrays, edges 1 and edges 2, of length n minus 1 and m minus 1 respectively, where edges of I equals to a comma b indicates there is an edge between nodes a and b in the first tree, and similarly for the second tree. You must connect one node from the first tree with another node from the second tree with an edge. Return the minimum possible diameter of the resulting tree. The diameter of a tree is the length of the longest path between any two nodes in the tree. So what they are saying is that in the input, we are given two 2D integer arrays, which is edges 1 and edges 2, which basically denotes the edges that we are having in two trees, right? So we are given two undirected trees, right, which are having n and m nodes, right, and the edges in them are n minus 1 and m minus 1 respectively, and all the nodes are numbered from 0 to n minus 1 in the first tree and 0 to m minus 1 in the second tree, right? Now make a note, it is not a binary tree, it is an undirected tree, which is technically a graph, right? So now what we need to do is that in these two trees, we must connect one node from the first tree with one node from the second tree, right? And when we connect these two nodes with an edge, we need to connect them in such a way that whatever is the resulting combined tree that we get, we combine them in such a way that we get the minimum possible diameter of the combined tree, right? Now, first of all, what is diameter? So see, diameter of a tree is nothing but the length of the longest path between any two nodes in the tree. So if I have a look at this tree, then what is the longest path between any two nodes in this tree? So if I consider this and this, between this, the path is this one only, the length is 1. This is not the longest path. The longest path is this or this, right, or this. Its length is 2. So for this tree, the length of the longest path between any two nodes in the tree is 2, right? So the diameter of this tree will be 2. Okay, so that is what diameter is, right? Now we have to connect one node from the first tree with one node from the second tree, right? So let's suppose these are the two trees given to us. Now, if I connect these two nodes, right? So this was my longest path in the first tree and this was my longest path in the second tree. So what I did was that I connected the two extreme nodes of both the trees with each other, right? Now, what will be the diameter of this resulting tree? So the longest path is this 1, 2, 3, 4, right? This is the longest path. So earlier, the first tree was having the diameter as 2 and the second tree was having the diameter as 1, right? When I joined these two nodes, the diameter of the new tree is 1, 2, 3, 4, right? So the new diameter is 4. But is this the minimum possible diameter? What if instead of connecting these two nodes, I had connected these two nodes? Then what would happen? What would be the new diameter? 1, 2, 3, right? The diameter would be 3, which is smaller. So we should connect these two nodes to get the minimum possible diameter, right? Let's take another example to understand it better. So if you see these two trees, right? If we try to find out the diameter of the trees individually. So for tree 1, which is the longest path? 1, 2, 3, 4. This is the longest path, right? So the diameter of the first tree is 4. Then what is the diameter of the second tree? 1, 2, 3, 4, right? So this is also 4, right? Now which two nodes should I connect? So the path that I had considered was this, this and this, right? And here I had considered 5, 2, 0, this one. 1, 2, 3, 4, right? These were the paths that I considered, right? Now, if let's suppose I connected these two nodes, right? Then what would be my diameter? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is my diameter. So let's try to minimize it. See, when I know that this is the longest path, right? When I know the longest path in my trees. So what if I take the mid node of that longest path? See, in this longest path, which is the mid node, it is node 0, right? Here, in this longest path, which is the mid node, node 0. So I am saying I will connect these two nodes with each other. When I will connect these two nodes with each other, then what will happen is that the new diameter will be 1, 2, 3, 4, 5. That's it. If you see other parts also, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, right? In every way it will be 5. When we connected node 6 with node 5, we got a diameter of 9. But see, now we have got a diameter of 5. Why? Because from the longest path, when we took the mid node from both the trees, then what we did was that we reduced the diameter of each of the trees individually by 2. Right? If you see here, earlier the diameter was 4. This was the longest path. But now when I have connected the mid node with this mid node, so now from this tree, we are getting the contribution as 2 only. And then from this tree, we are getting a contribution of 2 only. And then 1 is this edge that we had connected, right? So this earlier was 4. Now it is reduced to 2. 4 by 2, 2. Here also it is reduced to 2. 4 by 2, 2. Right? And then plus 1 is the new edge that we had added, right? So can I say that if you identify that what is the diameter of tree 1, that is D1, and the diameter of tree 2, that is D2, right? And then you take the half of it. Basically, you divide them by 2. And then whatever you get, if you add a 1 to it, that will be the new diameter of the combined tree, right? But there are few edge cases to notice over here. The first edge case is, what if the diameter is an odd? So basically, if let us suppose that we had a node here, then in that case the longest path would be 1, 2, 3, 4, 5, right? So tree 1 should have a diameter of 5. In that case, when you would connect this node with this node, mid would be again node 0 only, because in one of its side it will be having a path of length 2, and on the other side it will be having a path of length 3, right? So for that, what we can do is that instead of just dividing by 2, we can take a seal of this, right? So when you will take a seal of this, then here the diameter was 5, right? So 5 divided by 2 will give you 2.5, and the seal of it will give you 3, right? Which is the new diameter. So 3 plus 1 this, and then 2. So 6 would be the new diameter, right? So one is this edge case. So basically the formula that we got was seal of D1 divided by 2 plus seal of D2 divided by 2 plus 1. This will be the new diameter, right? But let's talk about other edge cases. If let us suppose the first tree looks like this. So here the diameter is 1, and the second tree looks like this, right? So here the diameter is 6, right? 1, 2, 3, 4, 5, 6. So now mid node is this. Here both are mid nodes. Let's connect, right? So this will be the new tree. Now according to your formula, your new diameter would be 1, 2, 3, 4, 5. Your new diameter would be 5. But no, if you see, still the longest path is this 1, 2, 3, 4, 5, 6. The diameter is still 6, right? The new diameter that we have got 5. But the diameter of the second tree was already greater than this new diameter, right? So after combining, the diameter will remain the same. So basically, the diameter is bounded by the maximum of these three values, right? See, when you are adding this edge, it is not possible that the longest path will always contain this edge. As in this particular case, this is the longest path. The new edge is not included over here, right? So just finding out this and returning it as our answer won't work. We need to find a maximum of D1, D2 and this new diameter, right? So basically our answer will be maximum of D1, D2 and the new diameter that we have got. And this new diameter was nothing but the seal of D1 by 2 plus seal of D2 by 2 plus 1, right? So this is how we will be able to identify our answer, right? Now the only problem left to solve is that how do we calculate this D1 and D2 for our individual trees, right? So let's see that. So if let us suppose that I have a binary tree which looks like this, right? Now how do I identify the diameter over here? So in a binary tree, it is easy to identify. See, this is the longest path, right? This is 1, 2, 3, 4, 5. So the diameter of this binary tree is 5. But here in a binary tree, the path was going through this root node. We are given an undirected tree where any node can be our root node, right? So here it was easy to identify. And how would you identify the diameter over here? So I should know that for this particular node, what is the longest path which is present on its left and what is the longest path which is present on its right. If I will sum up those two, then I will be able to get the diameter of this tree which is passing through this particular node, right? So from the left, the longest path will be 2. From the right, it will be 3. So for this, 2 plus 3 will get 5. So the diameter of this tree passing through this node will be 5, right? And how will you identify that? So we can apply DFS over here, right? What we can do is we can recursively go till the leaf node, and then when it will go back, then we can return the diameter. So see, we need to find out the diameter, and diameter can be find out with the help of the path, right? So we will have to return two things from each node. One will be the diameter and the next will be the path, right? The length of the path. So two things we will be returning. So see, for this node, I want this leaf node to return a 1, and from here I want to return a 0 because no child is there. Then for this node, what will be the diameter? 1 plus 0, that is 1, right? For this, 1 is the diameter. Then if I see for this node, so here it is 2, here it is 1. So this should return 2, this should return 1, and then it should calculate its diameter as 3, right? So this particular node, this should return a 1 over here, right? This will return a 0. So for this, diameter will be 1. But it will return diameter also as well as the path also. So the path is 1, right? So see, diameter will be the sum of the two that we have got from both the left and right. But what will be the path that this node will return? So if I say for this particular node, from here you will get a 2, from here you will get a 1, right? So diameter will be 3, which is the sum of these two. But what will be the path that you will return? Maximum of these two, right? Because diameter will be find out with the help of longest path. So out of these two, whatever will be the maximum that you will return, right? So this particular node will return 2. But this edge is also there, right? So whatever this will return, it will return it with a plus 1. So from left and right, whatever is the maximum that it had got, that maximum plus 1, it will return to the parent node, right? So this is what the logic is. But now in our case, as I said, we don't know what is the root, right? So basically, since in our undirected tree, we can get the maximum diameter at any point. So we will have to maintain at each point for each node. We will find, is this the maximum diameter? Is this the maximum diameter? So that at the end, when we come to the node from where we had started, we are having the maximum diameter of the entire tree, right? Now, in our case, it wasn't a binary tree, right? It was something like this, that a particular node can be connected with, let's suppose, 3 nodes or 4 nodes, and they can be further connected to any number of nodes, right? So now in this particular case, that is in our case, how are you going to identify the diameter or the path? So see, in this particular case, what we were doing, we were taking what is the longest path from the left and what is the longest path from the right. But in this particular case, one node can be connected to any number of nodes, right? So this would be returning a 1, this would be returning a 2, and this would also be returning a 2. If I add one more node here, then from here it will get 1, from here 2, and from here 3. Now out of these 3, what 2 are you going to select? The two greater ones, the largest one and the second largest one, 2 and 3, because that will give you the longest path. This is the longest path, right? So whatever are the two maximum paths that you will get for a particular node, those two you will consider in your diameter, right? So that is what will be different for an undirected tree, right? So looking at the code, you will be able to understand better how are we calculating it. So basically the idea is to apply DFS in our undirected tree, and we can start with any node. Let's suppose node 0, right? We can start with node 0 and then we can apply DFS, right? And in that DFS, we can also pass a parent node along with the current node, right? So one will be the current node, right, on which the DFS is applied, and we can also pass the parent node. Why parent node is needed? So that we do not form a cycle. For each node, we will be checking what its neighbors are, right? So for parent, we won't check that because that will form a cycle, right? And we do not want to end up in that cycle, right? So that is why we will also maintain a parent. And if one of the neighbors of our current node is parent, then we won't take that into account, right? So for both of the trees, the tree 1 and tree 2, we will apply DFS, right? So that DFS will basically run for all the nodes in that tree, right? So if let us suppose that the number of nodes in the first tree is n and the number of nodes in the second tree is m, so your time complexity would be order of n plus m, right? For the DFS of both the trees, this will be the time complexity. And what will be the space complexity? So first you would be creating an adjacency list, right? Because in the input we are given the edges 1 and edges 2. With the help of that, you will create an adjacency list, right? And then you will apply DFS, right? So for that adjacency list, you will be consuming a space of order of n plus m, right? And for DFS also, the recursion tree will be taking order of n plus m space. So space complexity will also be n plus m, right? So let's quickly look at the code. So first of all, let's take out the total number of nodes in both the trees. So in the question, it is mentioned that the first tree is having n number of nodes and n minus 1 number of edges, right? So with the help of edges 1 dot size plus 1, I can identify n, and with the help of edges 2 dot size plus 1, I can identify n, right? Now, with the help of edges, I want to create my adjacency list, right? So I will create a vector of vector int, right? I'll name it adjacency list 1, and then we can create a function because we want to do this 2 times. Adjacency list will be created for both the trees, so we can create a function, let's suppose build adjacency list, and in this we can pass the total number of nodes and our edges vector, right? Similarly, we will do it for the second tree. So vector vector int adjacency list 2, we will call the function build adjacency list. In this we will pass the total number of nodes and the edges vector, right? So let's create this. So here this will return us a vector of type integer, right? Its name will be build adjacency list. Now it is receiving the total number of nodes. Let's name it size, and then it is receiving the edges vector. So vector vector int edges, right? Now for returning our adjacency list, we will create a vector of vector, right? Let's name it adjacency list, and its size will be equals to the size that we have received. And then we will run a for loop that for auto edge in edges, right? So now since this is an undirected graph, so we will have to push in both the nodes, right? If the pair is u comma v, then in u also we will push v, and in v also we will push u, right? So in the adjacency list for edge of 0, right, we will push back edge of 1, right? And in the adjacency list of edge of 1, we will push back edge of 0, right? And then at the end we can return this adjacency list, right? So now that we have created the adjacency list for both of the trees, we now need to find out the diameter of both the trees, right? So int d1 will be equals to, let's create a new function for finding out the max diameter. So this will receive the adjacency list. So adjacency list 1, and it will receive a current node which will be 0, right? In both the trees, the nodes are marked from 0 to n minus 1 and 0 to m minus 1 respectively, right? So we can start with node 0. There is no node that is a parent node, right? Any node can be our parent node, but since we will be calculating the maximum diameter for each of the nodes, then we can choose any of the node as our parent, right? And this won't be having any parent node as of now, so we'll pass a -1 for the parent node, right? And as I said, this DFS will return us two things. First will be the diameter, and the second thing will be the path, the longest path, right? We need only the diameter, so we will do a dot first. Basically we will return a pair from this function, so we want only the first value out of that, right? Then the second diameter will be equals to find maximum diameter adjacency list 2 node 0 parent -1 dot first, right? Now out of these two, the new diameter will be C log d1 divided by 2.0 plus C log d2 divided by 2.0 plus 1, right? 2.0 because d1 d2 are integers, right? And then we can return the maximum of d1 d2 and the new diameter, right? So now let's implement this function find max diameter. So this is going to return us a pair. Both the values will be integer. The name is find max diameter. Now it is first going to receive the adjacency list, which will be a vector of vector, right? Let's name it adjacency list. And it will receive the current node and it will receive the parent node, right? Now inside this, what do we want? We want the maximum diameter. Let's keep it as 0 initially, because for the leaf node it will be 0, right? That is why. And then we want the two maximum paths, right? Or the two maximum depths for that node, right? So we will create two variables. One will be the max depth 1, which will be 0, and another one will be the max depth 2, which will be 0. Again, for the leaf nodes, the depth will be 0. That is why the initial values are 0, right? Now what we need to do is we need to check for all its neighbors. So int neighbor, this will be in the adjacency list of the current node, right? So basically, we will be identifying that what is the diameter for the neighboring node, right? So what we will do is that we will call this function for the neighbor, right? We will call this function find max d for the neighbor. So we will pass the adjacency list, we will pass the neighbor, and for this neighbor, what will be the parent? The current node, right? So this is going to return us two things. One will be the diameter of the child and the next will be the depth for that particular node, right? Now, as I said, in this, for avoiding cycle, we will have to put a condition that if the neighbor is equals to the parent, then we will continue over here. We do not want to run this function for the parent, right? So now that you have got the diameter of the child and the depth, now this max diameter can be a maximum of the max diameter itself or the child diameter, right? Because we are calculating the diameter for each of the nodes. Basically, we are finding out the longest path running through that particular node, right? So for each node, we are getting a diameter and we are identifying what is the max diameter, right? And then we have received a depth. So see, we will be doing depth plus 1. Why? Because when this node got 2 from here and 1 from here, when it will be returning a value to its parent, this edge has also to be included, right? So out of these two, it would return 2, right? But this has also to be added. So it will return 2 plus 1, that is 3. That is why this one is what we are adding in our depth. So that's why we have done depth plus plus over here, right? Now, we need to identify that what are the max 2 depths, right? Because this was our undirected tree. That is why we should know what are the two max depths, right, for each of the neighbors. So if this particular depth, right, if the depth for this particular neighbor is coming out to be greater than the max depth 1, right? So in that case, max depth 2 will be equals to max depth 1 and max depth 1 will be equals to this particular depth, right? Else if this depth is coming out to be greater than max depth 2, then in that case, max depth 2 will be updated to this particular depth, right? So once it is done for all the neighbors, then in max depth 1 and max depth 2, you will be having the two longest depths in these two variables, right? And then for the childs, we had updated our max diameter. But then these two max depths that we have got, we need to do their sum, right? And then that sum could also be our diameter, right? So after this for loop, in the max d, we will update it to the maximum of the max diameter, comma, max depth 1 plus max depth 2, right? And at the end, what are we going to return? We are going to return the max diameter, comma, what is the maximum depth? That is max depth 1, right? So this is how our code will look like. I hope I have not done any typo. Let's run this and check. Okay, so this should be paired. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.